Hi guys, welcome to PCMINR.com and you're watching this video on equations of motion by Sonal Gupta. In this module, we are going to derive the three most important equations of mechanics and we call them as equations of motion. So one is the equation which represents the relationship between velocity and times, that is v is equal to u plus at. This is our first equation of motion. Second one represents the distance-time relationship, that is s is equal to ud plus half at squared. This is the second equation of motion. And third one is representing distance-velocity relationship. So this is the third equation of motion. And before we start deriving the equations of motion, we should know all the notations we use. So displacement is denoted by s, initial velocity will always be u, final velocity will always be v, acceleration of the motion will be a, and the time interval would be t. So these are the general notations that we are going to use when we are deriving the equations of motion. So let's start. So let us assume an object with mass m. It's moving with an initial velocity u. Now when some force is applied and it changes its velocity to v, and all this happens in the time interval t, and the distance covered to change the velocity from u to v is s. And we know that acceleration is the rate of change of velocity, that is, acceleration is change in velocity upon time. Therefore, I would say change in velocity, how would we find out? Final velocity minus initial, that is v minus u upon t. So this is also the definition of acceleration. And now if I cross multiply this, I get at is equal to v minus u, or I can write it as, if I bring u this side, so I'll get v is equal to u plus at. So the first equation of motion has been derived from the definition or the formula for acceleration itself by just rearranging the terms. Quite a simple one. So now we move to the second equation of motion. Again, we are going to use the formula of acceleration, that is a is equal to v minus u upon t, because we are talking about the same object as we said here, going from u to v in time t. So then what is the time t here? It will be v minus u upon a. So just take t up and bring a down. Now, I also know that average velocity is, the distance is also known as average velocity into time, right? So average velocity into time also gives you the distance traveled. So that means that s is equal to average velocity is u plus v by 2. So if we just have two velocities, then the average velocity is u plus v by 2 into time. I can write as v minus u by a. And if I write this as u plus v or v plus u, and using the identity a plus b into a minus b is a square minus b square, so I get v plus u into v minus u as v square minus u square upon 2a. Just multiply these two using the identity. So s is this, and if I take this cross multiplication, then v square minus u square is equal to 2as. So we are done with the second equation of motion. I think that is also quite simple. Just using the formula for s, average velocity into time, and since we don't have t, so we have to eliminate t in terms of v minus u by a, and so you just get the answer, average velocity into time. V square minus u square is equal to 2as. And now we move to the third equation of motion. So that is s is equal to ut plus half at square, and as we can clearly see that there is no v here, so we are going to eliminate v. How do we do that? Now the formula for distance, again we'll use average velocity into time, that is v plus u upon 2 into time t. So we won't replace t this time. Now v, according to the first equation of motion, is u plus at plus another u upon 2 into t, and now you just multiply t in the numerator, and u plus u is 2u, so you have 2ut plus at square upon 2, right? So s is equal to this, and I can split these terms as s is equal to, I can write this 2ut by 2 as ut, right? I can write a 2ut by 2 and at square by 2, so it's ut plus half at square. So we get the third equation of motion. So this was the simple analytical method of deriving the three equations of motion. Now we'll move to the graphical method of derivation of these equations. So let's see the first equation of motion from the graph. So here is a velocity time graph, and we have velocity time graph which is a uniform one. So this is 0 from O to A, or it's moving with some initial velocity u, and then we say that it reaches the point A, it starts accelerating and it reaches the point B. So all this time we say OA, this represents the initial velocity u, and BC, this represents the final velocity v. Then what is BD? Then up to this portion, BD you can find is total BC minus DC, so that is V minus U. Therefore, now we can find out our equation of motion from the slope of this graph. Now we know that slope of a VT graph gives us acceleration. Also, the acceleration, the slope here is equal to BD upon AD. And what is BD? BD is V minus U upon AD represents, this way we have the time interval t. So V minus U by t is equal to A. Therefore, we say V minus U is equal to AT, or V is equal to U plus AT. So we get the first equation of motion from the graph. Now from the same graph, if we find the area of the VT curve, we know that area of VT curve gives us the distance traveled. So distance or displacement, and that is represented as S. Therefore, S is equal to the area of the trapezium here. So we have a trapezium OABC, and the formula for area of trapezium is half into sum of parallel sides, that is OA and BC, which are parallel sides, into the distance between them, it's this AD. So half into OA plus BC into AD. Now this gives us half into OA plus BC, that's U plus V into T, and that is half into U plus V or V plus U times T can be written as V minus U by A, as we know from the first equation of motion. Therefore, and this is S. So again, taking this 2A on the left hand side, and above we just apply the identity A plus B into A minus B. So we have V square minus U square upon 2A, and when I take this 2A here, I get my second equation of motion, that is V square minus U square is equal to 2AS. And for the third equation of motion now, we again use the same formula, that is area under the VT curve gives us the displacement S. But this time we don't use the formula of area of trapezium, we rather divide this as area of a rectangle and area of a triangle. So we add the two. So I get area of the rectangle OADC, that gives me length into breadth, plus the area of the triangle is half into base, that is AD, times the height of this triangle, that is B into D, and that is V minus U. length into breadth is ut plus half times AD is again equal to t into v minus u. Now v minus u can be written as AT. So I get ut plus half AT squared. Thus we see that from the same graph you can find the three equations of motion. For the first one we use the slope of the graph, and for the other two equations we use the area under the VT curve. And this is how you can derive all the three equations of motion graphically and analytically. I hope you found the video helpful, and please do subscribe, like and share, and follow us on Instagram and Facebook at PCMINR.com. Thank you.